finishing up number 9 on the bottom of page 6. We were just writing no solution when the video ran out. And then I wanted to remind you, no solution means no points of intersection. Therefore, we can assume the lines are parallel. If I were to graph both of these, they would be parallel. And remember, that's called an inconsistent system, not your typical where two lines intersect in one point case. Okay, next page, we're going to learn our last method. So think about the methods we've learned so far. The first method we learned was graphing, which was great, but it's not very good if your answers are fractions. Remember these ugly fractions over here? Do you think we would have been able to find that point on the graph? No way, not with that precision. So that's why a graphing method, although it's nice, it's visual, it lets you understand what you're doing, it's not great if you don't have whole number solutions, for example, like this. So that's why we have to learn the other methods. So after graphing, the method we've been working on in the last couple videos, remember, was called substitution method. On the test and on the final, I do ask you for specific methods, so make sure you know them by their name. And the name kind of like describes it. Substitution, what are you doing? You're plugging one y in place of another y, so that's why it's called substitution. This next method, method number 3, is called elimination, and some textbooks also call it the addition method. Let me take a quick drink. Sorry about that. So the elimination method or addition method, and I'm not sure which one Alex calls it, but whatever it calls it on your homework, it's going to call it the same name on your test, so you'll be familiar. And both names are appropriate. Elimination's appropriate because we're going to be eliminating one of the variables, but addition's appropriate too because one of the steps on this new method is adding the two equations together. So I like both names. They're both very descriptive, and elimination is a good name too because see what happens here? Negative 6y plus 6y eliminate. So I'm not sure which name Alex calls it. It might interchange and call it both names. So, whatever, just make sure you recognize it when you take your test and final. So these are the steps we use to solve using the addition method or elimination method. So first we line up like terms. So we make both of our equations look like ax plus by equals c. Remember how that's called standard form? So x is first, the y term second, the constant or the number without a variable is over on the right by itself. Then we pay attention to the coefficients of the variables. If they are opposites, we add the two equations together and eliminate the variables that are opposites. For instance, aren't negative 6y and positive 6y opposites? So we draw a line through and we eliminate the y variable, because remember, we only know how to solve an equation with one variable. We don't know how to solve it with two. But sometimes they're not going to be opposites. So we have to pick a variable we want to eliminate. I almost always just use the x just because it's first and it's easy, but doesn't matter. And then we have to multiply one or both equations by something that will make the variables opposites. And I know here in this in words it doesn't make a lot of sense, but you'll see it in play here in a moment. Then we add the two equations together, combine the left sides, combine the right sides. Don't forget to eliminate the variables that are opposites. So don't write y here, don't write 0y, just eliminate them. And so then you produce an equation in one variable, which you can see right here. We solve the resulting equation. Divide by 18, and we get our x or our y. And then we substitute that x or y into one of the original equations to find the other variable. And as usual, we always write our answer as an ordered pair, because remember, solving means finding the point of intersection. So we're looking for where these two lines cross. So we don't need to solve for y on this method. This method's totally different than substitution. Substitution requires one of the equations has to be solved for y. Elimination method or addition method wants them both in standard form, an x, a y, and then on the other side of the equal a number, an x, a y, and on the other side a number. So on this one, I'm choosing to get the y's to cancel, and because I chose that is because they already have opposite signs. So I need one to be a number and one to be the opposite number. So in my head I go, what do 3 and 2 go into together? Oh, 3 and 2 both go into 6. So how can I make this -6? Multiply by 2. How can I make this +6? Because remember, I'm trying to make opposites. Multiply by 3. So I need one to be -6. I need one to be +6 so that they will eliminate. So now I take my two original equations and I multiply this one by 2 so that that will turn into -6. And I multiply this one by 3 so it will turn into +6y. So 12x minus, let's draw our arrow so we don't forget. I will tell you the most common mistake. Students forget that term over there. So draw your arrows so you don't forget it. Another thing that's a really good technique is if you get really ugly answers like 5/7 or -54 30 seconds or something like that, go back and check and make sure you remembered to multiply these, because that's almost always where the mistake is. Did you multiply that by 2? Did you multiply that by 3? So if you get really ugly answers, go back and look and make sure those are correct. So 12x minus 18y, 12x minus 6y equals -18. 12x minus 6y equals -18. Then multiply each of these by 3, and I'm going to get 6x plus 6y equals -18. 6x plus 6y equals -18. Then, like the directions say, eliminate the variable that you just made opposite. 6 minus 6 is 0, so it's gone. And then we add, and that's why this method's also called addition method. We add the two equations. So 6x and 12x is 18x. -18 plus -18, those do not cancel. They are not opposite, so don't cancel them. When the signs are the same, we add and keep the sign. Then divide both sides by 18, and we get x equals -2. So the only thing I don't like about addition method, it's my favorite, but the last step is not so fun. I don't have a boxed equation that's all solved for y, so I have to go into one of the original equations to find the y. So I know right now I have -2 comma. Now I need to find the y. So I try to pick the equation that has the least negatives and the smallest numbers. So in place of x, I'm going to put -2, and you can ignore those numbers. That's for something else. So 2 times -2 plus 2y equals -6. So that turns out to be -4 plus 2y equals -6. Then I add 4 to this side, add 4 to this side. That's gone, and I get 2y equals -6 plus 4. 2y equals -2. Divide both sides by 2, and there's my y. So my solution is -2, -1. To check it, well, we already put it into the first one. So if you want to check it, you need to go into the second one. So plug -2 in here, plug -1 in here, and check it because we already did this one, right? So you would do, does 6 times -2 minus 3 times -1, is that going to give me -9? So I just rewrite the problem because I'm plugging in negatives. They have to be in parentheses. Is -12 plus 3 -9? Yes, it is. Ding, ding, ding. I got this problem correct. Happy dance. Oh, so as long as the two sides match, you have done it correctly. So let's go ahead and practice on one here. So, as the directions stated, it doesn't matter which variable you decide to eliminate. I could decide to eliminate the x's, or I could decide to eliminate the y's. So I could make this 3x and this -3x, or I could make this 2y and this -2y. I think in this case the x's would be the easiest. So they're not opposites. I can't eliminate them yet, but what could I multiply one of them by to make opposites? I could multiply the top one by -1, or I could multiply the bottom one by -1, right? Because I want to remind you what opposites are. Opposites mean they're the same number, but one's positive, the other one's negative. So I'm going to choose to do the bottom one by -1. So my top equation is going to stay the same. Because remember, that's your number one goal. Make opposites of one of the variables. So I could have made this -2 by multiplying all these by -2. But I just thought, oh, they're both 3 now. So if this is +3, let's make this one -3x. So then remember how I said always put your arrows in? Excuse me. So that you don't forget about distributing all the way across. So this turns into -3x, -2y. And since we're going to be adding, it's kind of nice to put that 1 there. And -10. So remember, step 2 says eliminate the opposites. 3 minus 3, 0. And I can't tell you how many people on the paper pencil test cancel them right there. 3 plus 3 is not 0. So do not cross them out unless they're the same number with opposite signs. Don't do sloppy math. 3 plus 3 is 6. 3 minus 3 is 0. So they have to be opposites in order for us to draw that line. And then we have 1 minus 2, which would be -1y equals, and this is an addition problem now, remember, 5 plus -10, which is -5. Divide both sides by -1, and I get y equals +5. So I am halfway done. So this is my y, so I put it in the y slot. And now remember, we can go into either equation. So like I said, it's easiest if you go into the one with smallest numbers. So I see this one has pretty small, nice numbers. And then we'll check it into the other one. So this says make y 5. So to check it, we have 3x, and let's just write check here. So when you look back at it, actually, we're not checking, are we? We are finding y. Okay. I'm getting a little Lulu, sorry. Too many videos today. So 3x plus 5 equals 5. So this isn't checking, this is finding the second variable. And then we need to solve. So subtract 5, we get 3x equals 0. What's the opposite of times 3? Divide by 3. Another common mistake on ones like this is students go, oh, there's a 0. This is no solution. No, it's not no solution. This is x equals 0.